All right, I've got the top of the hour, so we're going to get started. I hope everyone had a great Memorial Day weekend and you're off to a good start today. The focus on this presentation is on ways to build recreational trails for walking, horse riding, and light vehicle use, as well as different methods for stabilizing embankments near trails. I'm your host, Corey Schneider, a business development manager with Presto Geosystems. I've been with Presto for 18 years, providing technical assistance and site support for our entire product line. We are located in Wisconsin and manufacture erosion control, stormwater management, and porous pavement products that are used all over the US and the world. We sell through an experienced distribution network that can provide local assistance on all of your projects. I have everyone muted now, so if you have any questions during the presentation, please type them in the question window and I will answer them at the end. Here are the things I hope you get out of today's presentation. First, to understand how to properly build trails to reduce the impact to the surroundings, how different trail uses can affect the design, how to build through wetlands or other environmentally sensitive areas, and which products are most applicable for unique conditions that may be encountered. We're also going to touch on wall and slope design to ensure that embankments along trails remain stable. First, a little background on Presto. We worked with the Army Corps of Engineers back in the late 70s to develop GeoCell technology, and we have been innovating ever since. Our products have been used in nearly 200 countries and in every state in the US. We do pride ourselves in going beyond simply manufacturing and selling a product, though. We have experienced design engineers on staff. So you can go to our website, which is prestogeo.com. Fill out a short form and let our engineers recommend what specific type of GeoWeb or other product may be applicable for your application. We do also provide contractor support, so we will be on site to make sure that the product is installed not only correctly, but also as efficiently as possible. Presto operates in 3 general product areas: soil stabilization using our GeoWeb geocells, which can be used for load support, slope and channel protection, and building green retaining walls. Porous pavements, of which we have both vegetated and aggregate solutions, and lightweight reusable construction mats. Today, we will cover some GeoWeb solutions as well as our aggregate porous pavement product and a few of our construction mats. An important thing to keep in mind as we go through this webinar, the trails that are made with our products are all considered permeable trails. That is, there is no impermeable paved surface being placed. The final surface is going to be a stone or sand material. This lessens the environmental impact of the trail, reduces the amount of heavy equipment required for installation, often in difficult to reach locations, and improves the overall cost and speed of the project. We'll begin with what makes a good trail. The first aspect of the design is the reinforcement of the trail itself. Especially when the trail moves through sensitive areas, keeping the path intact is how you keep people away from damaging vegetation or getting lost while wandering. The trail needs to be clearly delineated and needs to be reinforced enough to stay in place over time. Using products specifically designed to act as the reinforcement of the soil or stone means the trail will last longer and will not encroach on the surrounding environment. The next key to a well-designed trail is drainage. Ponding water can ruin a trail surface, and water that runs off the trail into unreinforced areas can scour and damage those areas. As I mentioned, all the products from Presto are considered permeable, and it is precisely for this reason. By keeping the surface permeable, the water infiltrates at the point of contact right when it hits the trail. The water can then permeate down through the product and into the subgrade, entering the groundwater system. The water won't pond at the surface and it won't run off or collect outside the reinforced area. This keeps the trail in the same condition no matter the weather, so there won't be any flaws or failures created below the surface that you can't see. The last thing to consider when designing a trail is how to confine the surface. Loose aggregate stone or sand is easily moved under shoes, hooves, tires, and water, leading to ruts, holes, and generally damaged trail areas. When the trail surface is damaged, people are going to want to move around the damage, leading them off the trail and into unprotected areas, potentially disturbing sensitive environments. Keeping the surface in place is an important feature of the products from Presto. When the stone or sand is properly held in place, ruts cannot form and the material can't be washed away. This greatly reduces the amount of maintenance required because the trail surfaces aren't degrading. The first product we'll look at is the GeoWeb 3-dimensional soil confinement system. This is a geocell in generic terms, which may be something that you've heard of before. It's similar to a geogrid, but is 3-dimensional, so it has depth to provide true confinement and can be used in a wider variety of applications. The GeoWeb system consists of two main components: cell size and cell depth. The cells come in three sizes, approximately 8-inch by 10-inch, 11-inch by 12-inch, and 18 by 20-inch. The heights of 3, 4, 6, 8, and 12 inches. The combination of cell size and depth depend on the project details and loading requirements, but generally trails will use a 4-inch or 6-inch depth and a small or medium-sized cell. The seam strength is very important to the function of a geocell. The stronger the seam strength, the better designed the geocell is. A strong seam allows for heavier infill material, steeper and taller slopes, and better lifetime performance. The strength of the panel material, in our case high-density polyethylene, is also critical to the strength and performance of a geocell system. Here you can see a typical GeoWeb panel. It comes tri-folded, banded, and palletized. Each section has a nominal width of 8.5 feet with section lengths between 12 and 58 feet. The panels are flexible, opening like an accordion, so they can follow the natural contours of the work site without being confined to a rigid set of dimensions. GeoWeb and our accessories are 100% made in the USA under strict quality assurance and environmental control processes, sure to comply with all requirements for Build America, Buy America, and the Infrastructure Investment and Jobs Act. The GeoWeb system is a 3-dimensional cellular confinement system, meaning that the GeoWeb panels have individual cells that are filled with an infill material that ultimately makes the final surface of the trail. By confining the infill material, the system distributes the loads and prevents rutting, and the cells keep the infill in place so that it doesn't wash away from stormwater runoff or move with traffic. The surface of the trail is going to be stable no matter what infill is chosen and require very minimal maintenance for the lifetime of the project. Let's look at some different options for building stable trails with the GeoWeb system. Walk, run, cycle trails are meant for people, small animals such as dogs, and bicycles only. This type of trail is not meant for equestrian use. These are the most common types of trails and can go along shorelines, through urban areas, or through forests or parks. The flexibility of the GeoWeb panels allows for smooth, natural-looking curves. The panels can be held open with stakes, as shown here, but those stakes are generally not permanent. They can be removed once the panels are fully filled. The panels can be laid either along the length or width of the trail. They are easily field cut with a saw or landscape shears and are securely attached together. No matter the dimensions, there will be little waste as panels can be pieced together in nearly any configuration. This is the finished trail surface using a local granite aggregate and allowing vegetation on both sides. The trail is clearly delineated and meets up with existing paved trails in the distance. The GeoWeb panels will keep the trail in place and level, minimizing surface erosion and potential for runoff of contaminants into the adjacent water. This path used granite, but any type of stone is going to be acceptable as an infill material, with the only limitations being it should be angular and have a maximum particle size of 1/3 the cell depth. So you can use what is local to your area without needing to truck in expensive engineered aggregate. As I said, it's easy to field cut the GeoWeb panels to accommodate the trail dimensions, even rather narrow trails like this one between a road and protected wetlands. By having the GeoWeb panels create the trail, water runoff from the road won't wash dirt into the wetlands because the water will be able to infiltrate through the permeable GeoWeb surface, keeping the dirt surface in place for a nice jogging path. Paths through neighborhoods or urban areas can augment or replace traditional sidewalks in places where drainage is a concern. Replacing broken and ugly concrete sidewalks with gravel surface paths allows for flexibility in design and aesthetic and will improve the safety of the walkway for pedestrians. These types of trails are good for any typical sidewalk traffic, but can also be designed to support cars or trucks. A 3 or 4 man crew can install about 1,500 square feet of GeoWeb panels per hour, including laying a geotextile fabric and infilling the panels. The geotextile helps create a separation layer between the natural subgrade and the infill material, especially important in areas of very soft subgrades such as wet clay. The flexible nature of the GeoWeb panels allows it to conform to hills and dips in the paths and allows the system to be pitched to one side if needed. Because GeoWeb gives additional strength to the infill material through confinement, cross sections can be cut in half or more, reducing excavation, aggregate, and maintenance costs. We recommend overfilling the GeoWeb panels slightly when installing so that there is a wear surface over the panels and the plastic is not visible. This surface will become naturally compacted over time on the trail usage. Having the panels slightly overfilled helps protect the GeoWeb material from vehicle tires or other potential damage. Equestrian trails are next, and they have some different requirements than walking paths. Equestrian trails have to be hardy enough to stand up to horseshoes while remaining smooth enough to avoid damaging their hooves. Horseshoes can pick up a surprising amount of dirt with each step, and with their heavy concentrated point loading can cause fast deterioration of the trail. If the trail is designed to withstand horse traffic, it is more than sufficient to handle hiking, biking, and small motorized vehicles. A GeoWeb trail system was utilized for erosion control for these equestrian trails. The gravel surface is resistant to rutting, and the 1-inch stone size is easy for the horses to walk over. This aggregate path will not get muddy or create sinkholes, so the surface will remain ready for use even after rain or heavy use. Having a well-defined path also helps prevent damage to areas off the trail, and using the GeoWeb system allows for inclusion of natural markers, such as the large boulders we see here on both sides of the system. Now we're going to walk through a case study for a shoreline trail in the city of The Colony, Texas. This project was a multi-use trail along the shoreline of a lake. The trail will see pedestrians, bikes, small vehicles, and potentially equestrian traffic. The client, the City of the Colony, wanted to follow the natural contours of the shoreline, which the flexible GeoWeb panels can easily handle. There was concern about the potential for uplift under the system due to the very high water table and lake level fluctuations, so additional steps were taken to prevent this from occurring. A series of polyester tendons were run through the GeoWeb panels and were anchored multiple times per panel. The tendons, in conjunction with the final infill stone material, prevent the GeoWeb system from lifting and deforming due to groundwater pressures. This is good practice in wet environments with potentially saturated soils. A well-graded decomposed granite was chosen as the infill material as it was readily available in the area. Using local materials is encouraged, though any type of stone is acceptable as long as it is angular and allows good drainage. This means that you are going to want stone with limited fines so that water can percolate through. If the water can't infiltrate, you will get ponding at the surface, similar to a paved surface such as asphalt. So you want to make sure your infill material avoids this problem. And you should keep in mind that this material is going to be your final surface, so aesthetics may be a factor in choosing the infill material. Once the GeoWeb panels were installed, the infill was placed with a standard front end loader and then raked by hand to ensure all the cells were completely filled. The material should be placed on the outside of the panels as needed to match the final grade and meet up with the unexcavated areas. For ease of construction, you can drive your vehicles and equipment on the GeoWeb panels as soon as they are filled, right up to the limits of the filled area if necessary, so you don't have to wait for the entire system to be filled before using it. This can help minimize the impact of construction on the area, since you won't need to create access lanes or clear out excess vegetation on the sides. A small, smooth-barreled roller compactor finishes the job. This is where having the wearing surface of overfilled material mentioned earlier comes into play. The compactor isn't driving directly on the GeoWeb panels, and you can easily visually confirm that no cell is underfilled. Again, the stone infill should have minimal fines. Generally less than 10% is ideal. Avoiding fines in your stone allows the system to stay permeable and not get clogged. Trails built with the GeoWeb system are a great example of green infrastructure by not disrupting the water cycle or impacting groundwater flow. No additional stormwater infrastructure is needed when the trail surface is permeable, so there is minimal impact on the environment around the trail. Here we can see the nice clean trail created using GeoWeb, allowing for most uses without having to worry about needing constant maintenance. This path is clearly delineated while maintaining a natural look that people won't mind seeing in their backyards. A few months after installation, there was a massive rainfall event over 7 inches in a 3-hour period, which can be incredibly damaging both during and after the storm. Several portions of the trail were flooded to the point of standing water at the surface on and around the GeoWeb protected areas. But thanks to the GeoWeb system and the extra precautions, such as the tendon system, the trail was not washed away as you might expect from an unprotected gravel trail. The trail was still usable, allowing maintenance workers access to the damaged areas for inspection and repair. No repair was needed to the GeoWeb system, and once the water was able to infiltrate, the trail was as good as new. When there is such a large rainfall event, the groundwater becomes saturated and doesn't allow water to infiltrate, giving it no choice but to stay at the surface and become sheet runoff. The GeoWeb system protects the trail surface against erosion when this happens, with the cell walls functioning as a series of check dams, keeping the infill confined within the individual cells. Then when it is able, the water can infiltrate into the ground and the trail is still in good shape. In the spring of 2018, several storms violently swept through areas along southern Maine's coastline, devastating the beaches and trails of Fort Foster, a town-owned park in Maine. As you can see from these photos, the trails and maintenance roads were washed out. To reconstruct the washed out recreational trail and maintenance road, 6-inch deep GeoWeb panels were installed at the site and infilled with 1-inch crushed aggregate. There were sections of the trail that sloped down to the beach areas. To stabilize the 2-to-1 sloped areas down to the beaches, 4-inch deep GeoWeb sections were secured to the face of the slope using a deadman tendons and Atra tendon clips. Then the GeoWeb was filled with aggregate and covered with large riprap. By using the GeoWeb system, the park was able to armor the maintenance road, recreational trail, and slopes from future storm events. Here's a before and after photo of one of the trails. Since its original installation in 2018, the GeoWeb load support and shoreline protection system continues to perform as designed, allowing the community to once again enjoy the trail system and local beaches. Now we'll move on to another project, Colchester Causeway in Vermont, which was used as a walking biking trail across Lake Champlain and was blown out due to storms and had to be closed. The local distributor worked with the town and submitted a request for project evaluation through our website. Here you can see Presto's recommendation of the mid-sized cell 4 inches deep. Installation took place in November of 2019, and the trail is holding up well after several significant storm events. One of the biggest questions we of course get is about cost, especially if this is a new technology for you and your area. Having an idea of how much the GeoWeb system costs compared with other stabilization techniques is very important. So here we have a basic comparison for the GeoWeb system for a load support application, in this case a gravel surface road. The comparison shows the difference in both price and cross-section depth for an aggregate-only unreinforced section, a section using geogrids and geotextiles, and then 2 sections showing the use of the GeoWeb system, one with aggregate and one with salvaged on-site materials as the infill. You can see the GeoWeb system is both thinner and less expensive than the other methods, significantly so when on-site material is utilized. In fact, a 50% savings can be realized compared to the GeoGrid geotextile section, which does not allow for the use of most salvaged or on-site material, as high friction angle, well-graded material is required with the use of both grids and textiles. Of course, your aggregate costs and distance to quarries may vary, but this will give you a general idea of the savings that can be achieved with the GeoWeb technology. Now moving away from the GeoWeb system. This next option illustrates similar confinement of infill, but within a rigid paver structure, our GeoPave units. Unlike the GeoWeb material, which is typically 3 or 4 inches deep for trails, GeoPave units are 2 inches deep and made from recycled polyethylene. The GeoPave units have these rigid paver characteristics, with specific features needed for performance with aggregate infill. The main one I want to highlight is the monolithic mesh bottom. This is a molded in place mesh on the underside of the paver unit. This mesh keeps the stone infill from migrating under the unit, and the integrated nature assists in the overall rigidity of the paver unit. The lattice bottom spreads the load similar to a snowshoe, so the wheel loads do not create ruts. GeoPave units are locked together with a connection device to create a fully integrated contiguous pavement that is highly resistant to traffic stresses. GeoPave was designed using a finite element analysis and will not lift up over time as seen with other systems. And as I mentioned, the GeoPave unit is only 2 inches deep, which can be a real asset if the project requires a thin cross section due to buried utilities or high excavation costs. We'll now look at a few project examples. This project is an access trail for walking down to a swimming area on a lake. The walkway had to be ADA compliant so that everyone could use it. It was also important that the trail help reduce runoff into the lake, so the permeable nature of the GeoPave system was critical. You can see the eroded trail before stabilization, both the trail surface and the surrounding areas, and the new trail area on the right stabilized with GeoPave. The protected system will help prevent erosion from stormwater runoff and be a smoother surface for walking on for visitors. This is another trail in a wetlands area. Here, the GeoPave units were placed directly on the subgrade, but a geotextile separator fabric and a base layer of aggregate underneath the panels can be incorporated to support heavier loads or add additional detention. No matter the section, the entire system creates a flat, stable surface and supports the anticipated loads. The same principles that we discussed with the GeoPave system apply here as well. By using an open graded aggregate stone with minimal fines content, the water can infiltrate at the point of contact, reducing surface runoff, and the individual cells can find the aggregate, preventing rutting and washout of the stone for a stable walking surface. A major concern here was protecting sensitive tree roots from impact damage. The GeoPave units are a great way to provide tree root protection by creating a bridge over the roots, so there is no direct contact from vehicle or pedestrian loads that could harm the trees. This bridge lasts the lifetime of the GeoPave trail and allows the trees to grow unimpeded. One of the great things about building trails with the GeoWeb or GeoPave system is the amount of choice you have over the final look of the system. 2 rock colors were chosen at this site to delineate the parking from the walkways. A light colored crushed limestone was used for the parking areas, and a contrasting reddish brown buckshot crushed aggregate for the walkways. Additional delineation, such as concrete parking stops or snap delineators, can also be included to help create a sense of separation within the overall GeoPave system. This project ultimately earned LEED Gold for all of the low impact structure and landscape elements. Protecting the local watershed was the primary reason for the inclusion of the permeable parking and walkways utilizing the GeoPave system. These pavements also perform as natural on-site stormwater detention, storing water in the base for natural percolation without the need for a large isolated detention pond, which would have been an unattractive nuisance on site. The GeoPave units come in 20 by 40 inch panels covering approximately 5.4 square feet, but they can easily be field cut or staggered to accommodate curves, so you are not locked into a linear path. The system was a great choice for this project with a quick and easy installation. the ability to allow water to flow through the system and not run off into the pond, and providing a smooth, clean surface for walking. The standard GeoPave units are black, but a tan GeoPave is an option that allows natural blending with light-colored stone. Again, the options available for the final design of the trails are what make using this system so versatile and a great choice for any job. The last option for trail surfaces is the GeoTerra system, which are construction mats that are strong yet lightweight and don't require any fill. Because no fill is required, they are perfect for areas where infill resources are scarce. Because there is no infill material, GeoTerra trails won't kill the existing vegetation they are placed over. They are open on the top and bottom and allow for vegetation to grow through them for as long as they are in place, which is essential for minimizing environmental impacts for pathways. GeoTerra units cover approximately 5 square feet each and can be connected to cover as large of an area as needed. The mats are strong enough to support heavy vehicle and construction traffic loads and have enough flexural strength to bridge soft soils without warping or cracking. The GeoTerra units are connected with strong metal connectors to essentially form a floating road through wetlands with very soft soils. The connected mat system distributes loading across the pavement, minimizing potential for rutting or sinking in soft, muddy soils. In some areas of Alaska, hundreds of miles of ATV trails cut across wetlands and stream beds, causing extensive damage to natural preserves. ATV riders can cause the loss of vegetative cover and habitat values. GeoTerra mats offer a great solution for low impact access in these wet and environmentally sensitive areas. The preferred method is to place the units across the entire trail width, but in some cases, just in the wheel paths is acceptable. As planned, indigenous grasses regenerated through the permeable open-celled GeoTerra mats, ultimately semi-camouflaging the product with the natural environment and protecting the vegetation from damage. In this case, the system ultimately ended up as a permanent structure, and the GeoTerra mats will be able to last for as long as needed. For this last section, we're going to pivot from the flat surface of the trail to the embankments that may be alongside or near the trail. Green walls can help create the space for trails to run through and work with permeable trails to allow water flow and promote vegetation. The same GeoWeb GeoCell technology that creates the trail surface can also be adapted to create retaining walls, such as this vegetated levee. The GeoWeb panels are stacked vertically on top of one another to create the wall, allowing for more horizontal space for the trail to be placed. The primary benefit of the GeoWeb wall is to create a stable, natural living structure with vegetation for aesthetic appeal. The open front fascia allows rainwater to infiltrate. The wall structure can also absorb some runoff from the top of the wall, such as from walking trails. While vegetated walls are most common, aggregate-filled walls are also possible. Using the same open graded aggregate we have been talking about, water can infiltrate through the wall so there isn't runoff onto your road or trail. An aggregate wall may be useful when you don't want to worry about maintaining vegetation in an area, such as an emergency response space or in areas where vegetation is difficult to establish. The walls are designed as either gravity or reinforced walls in the same way as mechanically stabilized earth or MSE wall systems. An advantage they have over MSE block walls is flexibility in poor soil conditions. Their relatively lightweight and flexible nature allows them to tolerate reasonable differential settlement very well. Another advantage over traditional walls, such as gabion basket walls, is the relatively shallow embedment depth of the wall and the ability to create a very steep wall face, generally up to 80 degrees. It's always necessary to consider both live and dead loads that the wall will experience, especially when placed near trails or roads. Dead loads can be buildings or soil slopes above the walls, while live loads are for construction traffic and long-term vehicle traffic. When possible, the load should be placed away from the edge of the wall or fascia, but if that's not possible, the design will need to be robust enough to support and withstand both the live and dead loads. Having traffic barriers at the top of the wall, such as this wooden fence, will help keep the loads away from the GeoWeb system, which can help with the design. We'll now look at a vegetated retaining wall case study. This project was faced with having to retain soils in a very problematic soft soil area, but piling systems were expensive and they wanted to maintain the natural environment. Concrete and modular block walls were considered, but ultimately they chose the vegetated GeoCell wall for its natural aesthetics and lower cost. Here you can see the wall structure is constructed with a slight setback to allow for topsoil fill and vegetation in the front cell. The backfill material is a good drainable aggregate. The wall can be seeded either by mixing the seeds in the soil before installation or by hydroseeding or broadcasting once installation is complete. As mentioned, the system's inherent ability to withstand some differential settlement in soft soil environments was extremely important at this site. The wall had varying heights along its length, which was also easily accommodated with the GeoCell system. By using the GeoWeb wall, they didn't have to bring in invasive equipment such as augers or H-piles, speeding the installation process. Here is the completely vegetated wall. The horizontal terraces allow rainwater collection, helping to minimize runoff and erosion. Pretty much any type of grass or flowering vegetation will survive on these walls. So by using local vegetation, upkeep can be kept to a minimum. Presto Geosystems offers a free software for designing GeoWeb retaining walls and slopes. It is available on our website, which is prestogeo.com, and can be used by engineers and designers to determine if the GeoWeb system is appropriate for your projects. There are a lot of resources on the website on how to use and interpret the software, but we are always happy to help with questions or recommendations. So far, we have looked at trail surface construction and vegetated retaining walls. GeoWeb can also be used for erosion protection in a surficial manner. This is a good way to protect slopes against erosion when the slope is shallower than what would be required for a retaining wall and globally stable, generally around 60 degrees or shallower. If there are questions about this type of application, we are happy to talk through it. There are three main infill types for slopes, depending on the type of protection needed: topsoil, aggregates, and granular materials, and concrete. We will focus on topsoil and vegetation infill, as that is typically what is selected in trail applications to keep things looking as natural as possible. Here's a simplified diagram showing how the different system components interact with the GeoWeb to form a complete system. We will talk about each of these components next. To begin, we have our slope with some standard dimensions. The first thing to go down is the geosynthetic layer, which can be a geotextile, geomembrane, geogrid, or any similar product. These aren't always required, and we typically try to stay away from them in vegetated applications, but we can make recommendations based on project details. Then the GeoWeb is put in place. Note how the GeoWeb has a horizontal turn near the top of the slope. This is important for crest anchorage and erosion control. We have two options for anchoring. One is using stakes or anchors. They are placed mid-slope and at the crest. The number and spacing of stakes is project dependent. The other option is to use tendons and a dead man, with the dead man being a buried pipe, concrete anchor, or earth or rock anchors at the crest. The GeoWeb is then filled with the desired infill material, and if vegetated, an erosion control blanket or hydroseeding is used until vegetation is established. The ATRA key is the first component for a completely integrated system, connecting each individual panel of GeoWeb into a single web that covers the slope. It allows for fast installation of the GeoWeb and will last the lifetime of the project, ensuring that the slope is protected and that the GeoWeb system will not fail under anticipated loads. The specific engineering values of the ATRA key will ensure the system holds up to loading over time without the corrosion seen in staples or the failure of underperforming cable tie systems. As slope angle increase, the driving force of the infill material exceeds the available frictional resisting force, and additional anchorage is required. The ATRA anchors, which are ATRA clips on top of number 4 or 1/2 inch diameter rebar, hold the GeoWeb to the slope and penetrate into the ground. If corrosion resistance is required due to project conditions, Presto has a polyethylene ATRA speed stake that is designed to work with the GeoWeb. For long, steep slopes where the native soil is highly erodible, or over a surface that cannot be punctured, such as a liner, tendons can be used for anchorage. The ATRA tendon clips transfer the load from heavy infill material to the tendons and crest anchorage system. Only the ATRA tendon clip is specifically designed to fully transfer safely and securely the forces placed upon the GeoCell. Every accessory and every feature has been designed and tested to specifically work together so that we go from problem to design to construction solution with a system where the modeling replicates the real world forces. Now we'll take a quick look at a couple of slope protection projects associated with trails. The American Tobacco Trail is a 20-mile rails to trails project running from Durham County to Chatham County in North Carolina. This slope had to be reconstructed after it was excavated in conjunction with the replacement of a culvert. After the culvert was replaced, the slope was regraded to its original 1.3 to 1 slope angle, and it needed to be revegetated. The GeoWeb slope protection system proved to be the perfect solution. Another great example of using GeoWeb for slope protection on a trail can be seen here at the Lance Armstrong Bikeway in downtown Austin, Texas. And you'll notice here they planted shrubs into the cells instead of just using grass seed. So again, almost any type of vegetation will be suitable for or with the GeoCell. Generally speaking, if that vegetation would grow without being in the cells, it will grow in the cells as well. In summary, Presto Geosystems offers GeoWeb, GeoPave, and GeoTerra that can meet any trail design needs, as well as GeoWeb for earth retention and slope protection near trails. Each product is designed to protect the surrounding environment while offering a low maintenance surface that won't wash away during heavy rain events. We offer a complete solution, including connections and anchoring options. Part of our complete solution is our technical assistance. We provide free project design evaluations. As I mentioned earlier, the form is found on our website, which is prestogeo.com. You can fill it out with as much information as you have, including attaching documents such as geotechnical reports, and then it will come to our engineering team. Generally within 3 business days, but usually faster, we'll provide a complete design evaluation, including infill recommendations and anchorage requirements. At this point, we would get our local distributor involved if they have not been already, and they will be able to use our project recommendations to get you some budgetary costs shortly after you fill out the form. We will work with you to get you the best design for your project. We deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specifications, so you can deliver certainty and build with materials you can trust. We have made it faster and easier for you to obtain your PDH certificates. With our webinar dashboard, you can easily view our library of webinars and download PDH certificates for on-demand webinars completed. Your webinar dashboard will keep a record of the on-demand webinars completed along with PDHs earned. Please note that certificates for live webinars are managed separately from the on-demand webinar dashboard, so you won't find your certificate from today in there, but you will receive an email from GoToWebinar within the next 2 hours containing a download link to obtain your PDH certificate. In 2 to 3 days, you will also receive a separate email from Presto Geosystems with more information about accessing the on-demand webinar dashboard and with other helpful resources. If you do not receive either of the previously mentioned emails, please be sure to check your spam folder. Here's my contact information. I do want to thank you for attending and remind you that you can send questions to us at any time at info@prestogeo.com or directly to me at the email listed here. Go to prestogeo.com for a wealth of information, and don't forget to view our YouTube videos found by clicking on the YouTube icon in the upper right corner of our web pages. I'll answer questions next, but if you do have questions I don't get to or you think of a question later, you can respond to the follow-up email and we will be happy to answer your questions and help with project recommendations. So let me open up the questions here and see what came in during the presentation. I got a question about sending the PowerPoint presentation link to replay. As I mentioned on that last slide, within a day or so, this presentation will be on our webinar dashboard and you can review it as many times as you'd like at your convenience. Have we ever used GeoCells for golf courses? Yes, we have done some GeoWeb golf cart paths. Typically, they would be used like right at the end of the asphalt path where the carts typically will spread out. So yes, the GeoCells have been used for golf course applications. Does the product allow for horizontal flow? It sure does. There is perforations in the cell walls, so as long as we use a clean stone infill, we will get that horizontal as well as vertical flow. Do we recommend laying plastic sheet? I think you're referring to a geotextile below the GeoWeb. I think we kind of covered that. It's really project specific, but in nearly all load support applications, which we would consider a trail, we would generally recommend a geotextile below. What's the maximum slope it can be used on? Again, I think we covered that. Generally speaking, for flat installations, you won't need any permanent anchorage. But once we get over like 15 degrees for a trail application, we would typically put some stake anchorage in there to make sure that we don't have any sliding of the material over time. For trees and the GeoPave, won't roots lift up the paver? Yeah, if we're too close to the trees themselves, that certainly could be a possibility. One way to prevent that from occurring would be to put a base of clean stone underneath the GeoPave itself. With that, the void space in the clean stone is going to prevent the uplifting of the units with tree root growth. Does New York allow GeoPave and base to be considered as pervious? Yes, it does. Because GeoPave is partially exposed, a question about damage due to sunlight. All of our products are UV stabilized with carbon black or HALs, so even when left fully exposed to the sunlight, they won't begin to degrade for over 100 years. Can they be used under a multi-story building or retaining wall in soft soils? Yes, they can. If you're interested in having us take a look at these particular applications, you can fill out the load support request for project evaluation on our website. General maintenance for GeoWeb in particular, how often does the gravel need to be top dressed? I mean, that really depends on so many different factors, such as how often and with what type of vehicles the area is being utilized, if there are any slopes, if there's additional runoff. So it's really hard to say. Can Attra-Key be used for stream bank stabilization? Yes, it can. We have done laboratory testing that shows the key connection is just as strong as the ultrasonically welded stream, so no issues there. What is the material for tendons? We have tendons that are polyester, polypropylene, and Kevlar, and we can make specific recommendations based on infill and environment, as well as necessary break strength. Is snow removal with a plow or blower a problem? If you are going to plow these areas, we recommend that you either keep the plow blade up an inch or so, use plow boots, or use a rubber bladed plow. Snow blowers don't really cause any issues at all. A lot of general questions here that I really can't speak to. How does the cost compare to permeable pavement or concrete? Certainly a GeoWeb filled with stone is going to be much less expensive, but can't really give you the details. Again, I'd recommend a request for project evaluation. You can see what our solution is going to cost and compare that to the costs that you get for some alternatives. What is the lifespan? I think I've mentioned that, but it's well over 100 years. Are edge restraints ever needed with the GeoWeb? Not required. As long as the area around the GeoWeb finish grade meets the top of the GeoWeb finish grade, that's all the edge constraint you really need. Is 8 feet the maximum height for walls? No, we've got walls that are over 50 feet tall. 8 feet is the width of the GeoWeb panels, not the maximum height. Can this meet ADA requirements with aggregate? Certainly with the GeoPave, you should not have any issues meeting ADA requirements. The GeoWeb may vary based on the permitting agency, but I've never seen an issue with a GeoPave trail or any load support application being considered ADA compliant. Issue with snow removal, salts, or grit. Yeah, we would generally prefer you not throw any fines on top of this if we want to maintain long-term permeability. But the good news is with all the void space in these aggregate applications, you really aren't going to need any sand or salt because they're not going to ice over, because as soon as the snow melts, it's going to go through the system. Question about GeoPave sitting flat on the subgrade if it's not smooth. Yeah, if you're not using any base, then the subgrade is going to have to be smooth in order for the GeoPave to sit flat. But if you do have any base whatsoever, the base can be graded flat. Has this been used inside substations? Yes, we use GeoWeb and GeoPave in substations all the time. Yes, it is approved for use in Texas. What is the advantage of filling GeoWeb with concrete? You don't need any other forms or reinforcement, and we can reduce the concrete depth, so it can be a significant cost savings. So that pretty much covers the questions that I see now, and we are 3 minutes short of an hour, so we're going to call that good. I want to thank everybody once again for attending the presentation, and look out for that email from GoToWebinar within the next couple of hours. Again, check your spam folder if you don't see it by the end of the day. And then email from Presto Geo in the next couple of days. Thanks again, and hopefully you'll join us for future webinars coming up.